So for section 11.7, we're going to be doing some more graphing with parabolas. The problem is that this is currently not in our vertex form, so we need to be able to get it back into vertex form so that we can know the vertex and do a quick sketch whether it opens up or down. So the vertex, basically, how do I get from standard form? I go from standard form ax squared plus bx plus c. And how do I get that into ax minus h squared plus k? We use completing the square. So I've done this before. Before we had it set equal to 0, so this one's not set equal to 0. I will have some people that will do that. They'll set it equal to 0, but that can actually be a bad habit. So I'm going to encourage you just to leave it as f of x. First step to complete the square, we move the c. And moving the c isn't super necessary. I just would rather not add a different process here than what we've done before. So this is very similar to what we've done before. So now what would I do to complete the square? Well, our a is 1, our b is even, so this would be a nice easy one. It would be x minus half of 4 is 2 squared. Going up here, we have to complete the square. That 2 times 2 will give us a plus 4. And that's completing the square, and that is allowed as long as what we do to one side, we do to the other. And so now we have f of x minus 1 equals, and so we're going to solve back for that f of x. So kind of our step 1 here is going to be 1, complete the square. And then when we're done with that, we will solve, not slov, we will solve for f of x, and we'll have f of x equal to our standard form. So when we add the 1, we get f of x is equal to x minus 2 quantity squared plus 1. That's now vertex form. So I can go down here and I can graph the vertex. To identify the vertex would be at h comma k, so 2 comma 1. Okay, we know that since the a is a positive 1, the graph is going to open upward. So I could go to 2, 1 and draw a parabola that's opening upward. I did encourage you that something else you can do for a little extra credit there is to find the x-intercepts. The x-intercepts would be where this equation equals 0. So basically I can take either y equals 0 or f of x equals 0. So that's what I'm kind of talking about right here. So I set that equation equal to 0. And then I solve. I undo squaring by square rooting. And so then we get the square root of negative 1. So this will have no real x-intercepts. Not a big surprise if you look at the picture. There are no real x-intercepts. If you wanted to be a little more impressive on this, you actually could still solve this because the square root of negative 1 would just be plus or minus I. And then when I add 2, we would get that x is equal to 2 plus or minus I. Those would be the two imaginary x-intercepts. Basically, if x equals to plus I, we get the value of 0, and we get to minus I, and we get the value of 0. So those would be our x-intercepts. I encourage you, if you're feeling comfortable with this, we're going to definitely do this as we go into trigonometry and pre-calculus. We're going to be solving for the x-intercepts to this level. But what's nice is when you do all three of these, everything should match. Your vertex, right, should be above. Why? Well, if it were below and it opened upward, we would get x-intercepts. And so then things wouldn't agree, and I go, oh, I must have made a mistake somewhere. If the graph accidentally was to open down, let's say you made a mistake and made the graph open downward from the correct vertex, we would have x-intercepts. So by doing all three of these things, by finding the vertex, having the graph open up and down, and checking the x-intercepts, we're able to actually verify this graph using all three of these and making sure they all agree. I can also do this. I have some technology. What was our original equation? X squared minus 4x plus 4. Let's see. Let's see if that'll work. X squared minus 4x plus 4. Oh, it was plus 5. I was like, yeah, something's off there. How about plus 5? And that is what our graph looked like. Having a vertex at 2, 1, and opening upward with no real x-intercepts. What if I add x squared plus 4x minus 9? Well, we could find the vertex if this were in vertex form. Step 1, we'd move the C. F of x plus 9 is equal to x squared plus 4x. Let's complete the square. X, half of 4 would be plus 2 squared. Adding to both sides. Okay. So now we would have f of x plus 13 equals, to get that f of x by itself, we would subtract the 13. These can get way more complicated if the a is not a 1 or the b is not even. But for now, this would be the level of what I would be asking you to do. So where's the vertex here? Well, h, k, the h being opposite, so negative 2, comma, negative 13. Where are our x-intercepts? X-intercepts is where I would take the equation, set it equal to 0. We're like, oh, it has a negative, no x-intercepts. Well, let's see what happens when I solve this, because our first step is to add the 13. And so we get 13 is equal to, solving it, the square root of 13 is real. It would be plus or minus square root of 13 is equal to x plus 2. And then when I subtract the 2, we get that x is equal to negative 2 plus or minus the square root of 13. This has two x-intercepts. This is, by the way, this is not 1 point. This is not negative 2 plus root 13, negative 2 minus root 13. These are actually two different x values. X is equal to negative 2 plus root 13. X is equal to negative 2 minus root 13. What's the y value? Remember, we did this by setting the equation equal to. So the x-intercepts will always have a y value of 0. Those would be our x-intercepts. Okay? Write those down. So what should this graph look like? Well, it had a vertex at negative 2, negative 13. Negative 2, negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And opening upward. The A was positive. Well, where does it cross? Where are these x-intercepts? We found them, right? So we knew it goes through negative 2, negative 13, right? But where does it cross? Well, this point right here would be at negative 2 plus the square root of 13, comma 0. Square root of 13 should be a little bit more than 3. So this should technically be about 1 point something. I'm doing kind of a sketch. And this would be what? Negative 2 minus square root of 13. And this is everything I need to know about this graph. I know the intercepts, I know the zeros, I know the vertex, and I know it opens up. And all three of them match. Okay? I could take the original equation, x squared plus 4x minus 9. come on now, x squared plus 4x, and then, oops, minus 9. It's approximately what our graph looked like. Zoom down a little bit here. There we go. There's our vertex. Let me just zoom this out. View, zoom. How about view there? No. Should be under menu. Graph. Where is it? Oh, window zoom. There we go. So we'll just zoom out just a little bit right there. Alright, so what does that do? I can see our vertex at -2, -13, and it opens upward. It crosses at -2 plus root 13 and -2 minus root 13, comma 0. Alright. We're going to do just two more that are a little more complicated. This would be harder than the level you would expect to see on the test, but more to the level that you would be definitely doing in your trigonometry and pre-calculus. What makes this one more complicated? Well, our a is not a 1. So step 1, we would divide everything by the 4, including the f of x. See, that's where that 0 is going to matter. So we have f of x over 4 is equal to x squared minus 1/4 x. I don't know why I put that in parentheses. There we go. Plus 5/4. Step 2, we're going to move the c. F of x over 4 minus 5/4 x squared minus 1/4 x. We're now ready to complete the square. It ain't pretty, but it's possible. We do half of 1/4, or we multiply by 1/2. That gives us 1/8. Going up, we square it. 1/8 times 1/8 would be 1 over 64. So I'm going to add 1 over 64. Okay? So as soon as we do this, we're going to actually have it really close. F of x over 4, -5 over 4 plus 1 over 64. You could give them a common denominator. I'm going to go ahead and use my technology. -5/4 plus 1 over 64. I think I have a calculator that'll do that. -5/4 plus 1 over 64. And I would like that as a fraction. So let's go ahead and turn that into a fraction. So -79 over 64 equals this mess. We're going to add that over. And then we're going to multiply everything by 4. So what's that going to give us? F of x is equal to this 4. Clears out the 4 there, but it distributes. It's basically our a. So 4x minus 1/8 squared plus 79 over 64 times 4. The 4 would cancel, leaving us with 79 over 21. So what would this look like? Well, it would have a vertex at 1/8 and all the way up at 79 over 21, which is 3 point something. That's a 21. And this graph is positive, so it should open upwards. So am I going to make you do that? No, but this is the level, this is the type of stuff that we deal with as things get more complex. Let's do one more. Let's find the vertex on this. Okay, we need to divide everything by, including. That gives us f of x over negative 2 is equal to, how about x squared, minus 3/2 x plus 1/2. Move the 1/2. Okay. Complete the square. X minus half of 3/2 would be 3/4. Bring that up. That gives me 9/16. So we have f of x over negative 2. 8/16, 9/16. I think we're going to end up with 1/16. Subtracting that over. Multiplying everything by the negative 2. Negative 2, x minus 3/4 squared. That becomes plus 1/8. So our vertex would be at 3/4, comma 1/8. There is an easier way of getting the vertex on these. There is a formula. It's great for now, but it will fall apart as we get to more advanced mathematics. It becomes a little more complicated than it's worth. But if you hit the help me button on this, they will say to do negative b over 2a and then f of negative b over 2a. So how does this work? Well, you identify the a, b, and c, and you do negative b, that's negative 3 over 2 times a, negative 2, negative 3 over negative 4, or positive 3/4. Well, that's the x value, so that's kind of handy. How would I get the y value? Well, you do f of 3/4. You have to plug a 3/4 into the original equation. So negative 2 times 3/4 squared plus 3 times 3/4 all minus 1. And eventually that will simplify to. You don't have to believe me. Let's look at that. Negative 2 times 3/4 squared. Times 3/4 squared plus, I think it was 3 times 3/4. Is it plus 1? Let me double check. Minus 1. See, I'm going to screw everything up here. How about minus 1? Why are you doing this? I hate when this does this. Negative 2 times 3/4 squared plus 3 times 3/4 and then minus 1. Negative 2 times 3/4 squared plus 3 and minus 1. Okay, let's see what we get. As a fraction, how about 1/8? So it works. It's an option. If you're going on to pre-calculus, I'm going to encourage you to deal with this mess. Okay. If you're not, there's a bit of a shortcut. Not like super easy. Still, I think a little easier than do the whole completing the square thing. Last little element here. If we know that y equals x squared is a parabola opening up and down, well then guess what? We can also graph x equals y squared. X equals y squared is a parabola that opens left or right. It has a vertex form. Notice it's not y minus h, it's y minus k squared plus h. This time, the vertical shift is with the x. Last time, the vertical shift is with the y. Last time, the horizontal shift was with the x. This time, the vertical shift is the one that is opposite. Gets a little confusing, but like I said, this is actually kind of the more standard form. The a does the same thing. It reflects, so if it's positive, it opens to the right. Negative opens to the left. But the rest of it is basically the same. Okay. In the past, we had y equaled ax minus h squared plus k. That should make sense that the horizontal shift was with the x and was opposite, right? When I have x equals a y minus k plus h, notice the vertical shift is now it's with the y, and it's also opposite this time. So when I have x equals y minus 2 squared minus 3, if I asked you to graph this, we'd start by finding the vertex. The most common mistake is people will tell me 2, negative 3. You at least made it opposite, but you have to catch that that 2 is the k and the 3 is the h. So it's not 2, negative 3, it's negative 3, comma 2. H, comma k. This time the k is the one that's opposite. So you graph a point at negative 3, 2. And since the a is positive, since this is positive, this parabola would open to the right. If that a had been negative, it would be the same parabola, just opening to the left. So that's it for this. Don't make a big deal out of this section. There's some harder things that are really pre-calculus things, but we're just prepping you for that. Get through the homework. It shouldn't be too bad. And the y-squared, yes, I do need to bring that up, and you'll see a couple of those. That shouldn't be too much of an extension from what we already learned. So keep it up. We're almost done with Chapter 11.